All right, our next talk is by Daniel Ulrich. He's a Western New York native with a decade of experience in healthcare industry where he's worn many hats across infrastructure and operations, security, quality assurance, and web development. Born in Western New York, he earned a bachelor's in information security from SUNY Oswego and an MBA from the University of Buffalo, feeling his passion for blending technology and practical innovation. And this talk is an introduction to application security testing.
Thank you. The introduction kind of stole some of my about me slide here, but I see a camera there too. I tend to pace and walk back and forth, so hopefully I'm not out of the frame too much. But thank you for the introduction here. Happy to be speaking today. So my current position that I'm holding today is manager of performance testing and also application security testing for Highmark Blue Cross Blue Shield. I will say disclaimer, none of the stuff I'm talking about today has any association with my current position, but happy to share what I've learned over the last several years being in the application security testing space, and hopefully you guys find it valuable as well. It's just some of my interests and hobbies here. We just welcomed a daughter into the family back in February. It's my wife and I in the picture on the bottom there. We like to go travel and hike. So a couple of those pictures, one's from Utah. We got those cool slot canyons last summer before the baby came, and then also do some hiking in Colorado. That's Mount Blue Sky there as well. The picture on the top left on the screen there is my view from my desk at work. We're in Seneca 1 tower now on the 36th floor, so I have a pretty cool rocking space up there now I get to go to each day. So what we're going to be covering today, here's a high-level agenda. We'll do some introduction into the topic and testing in general, and then dive a little bit into application security testing. Talk about some of the program components from a high level, do a little bit deeper dive into a few of the testing types just to highlight and try to get a better understanding of, talk a little bit about triaging and reporting, and then getting started. Any of the talk today resonates with you and you want to learn a little bit more, I have a slide on some resources that are out there, learning resources, and to get started within the field. Also at the end, I'm going to try to do a live Kahoot. We'll see how this goes. I have some free t-shirts to give away, so we'll have a little game at the end of it. All right, so introduction into application security. Apps are pretty much everywhere today, as you guys all very well know. Apps are on your phone, you use web apps on a daily basis, and threat actors really do like applications. It's a nice way that they can find internet-facing apps that they can find threats out there on and exploit those threats. But taking a step back, where does application security fit in the grand scheme of things? You'll see this kind of rainbow chart on the screen here in the 7 different layers of security. Application is pretty close to your mission critical assets out there. So it's pretty important. It's one layer away from your company's gold or your organization's gold in the sense, and the only thing that sits between that is the actual data level of security as well. So that's what we're going to be focusing on today is the application layer. Just by show of hands, just curious, is anyone in a test engineer role today or doing any type of security testing in their day-to-day jobs? A few hands. Okay. All right, great. So this is more intended. I'm by no means an expert in these topics. I've been learning over the last few years and happy to share some information. The other thing to call out, where does application security fit into like the corresponding teams? And it's kind of in the middle of a few teams out there, and I try to represent with this honeycomb chart. You've got your DevOps engineering team that security testers will often work with, configuring your CI/CD pipelines. You have your developers that you should be consulting with and trying to educate them on the vulnerabilities that are discovered. You have your favorite governance, risk, and compliance folks who can set the standards and policies as a guiding light. Vulnerability governance as well is out there to help manage the open vulnerabilities within an organization. And last but not least, QA, the quality assurance organization. And depending on the size of your company, these may be separate teams and maybe one person wearing the hat across all of these functions. It really depends on the size of the organization and the industry that they're in. If it's a highly regulated industry like finance or healthcare, you're going to have more dedicated resources to this type of work. All right, so what are the risks or real stakes of application security? So when I was putting this presentation together, it was actually kind of hard to find a narrow list of real world attacks that have happened in the past couple of years that were exploited from application security fails. So I'm calling out a few here on the left-hand side of the screen. There's some outdated software leak that exposed some of customers' data from AT&T going back in 2023. There was an SCA fail, which we'll dive into in a little bit and talk about. Leaked cloud keys and secrets. This is very common. There's many instances of this happening, and we'll learn a little bit more in the Verizon data breach investigation report in a little bit. And then to call a couple other different types. Infrastructure as code is I don't want to say a newer concept because it's been around for a little bit now, but securing your infrastructure and making sure it's configured in the right way. Comcast leaked 36 million users' data based on leaving some AWS bucket leaked information out there. And then the last one, SQL injection, impacted United Health's 100 million patients exposed. 100 million, like, think about the size of that. It's almost like 1 in every 3 Americans' data was exposed in that breach alone. Like, that's wild to me, that scale, which could have been prevented or at least avoided from fixing a detectable issue with certain tools and processes in place. So the risks, we talked, financial hits. This is an obvious one. When a breach happens and you show up in the news, your stocks will typically go down. You'll lose a lot of investors, the trust with them as well, and not to mention the legal fees and headaches that you have to deal with after the fact, and all the work that should be done, rightfully so, to make your processes better, resulting in a breach. And then what about AI? So I feel like I had to include something about AI in this presentation since it's very relevant. Everyone's using AI in every day. So just show of hands, like I'm just going to go through a list of different AI agents. Who uses, we'll go through ChatGPT, any ChatGPT fans? How about Grok? Any, help me out, what other were popular? Gemini, yep, that's a big one as well. So everyone has their kind of preferred AI agent out there. And with it, it's very easy to generate code. It's progressed a lot in the last year or two. If you try to sit down and build a web application from scratch a year and a half, 2 years ago, which I tried, I struggled with it based on the code that was given. You try to do it this week, and it's much easier to spin something up. Now, whether or not that code is secure is another question. It's very easy to generate code, but is the AI at a point now where it's defaulting to generating secure code? I would say no, not saying it won't be there eventually, but it's made it even more important for these types of testing to be aware of, since it's made it more accessible for engineers to build stuff in the field. All right, so call out a few stats. Like I mentioned, the Verizon Data Breach Investigation Report. If you haven't heard of this report, Verizon does a good job and puts out a breach report each year. And it has a good high-level executive summary, and it even has some jokes and puns within it, so it adds some fun into the actual data itself. I'm not going to read through all of these, but a few of them called out. 30% of the breaches in their sample size involved a third party. So no longer is your company just your company. It's the partners you deal with. It's all the third-party software you pull into your product. So it's getting more and more challenging as time goes on to control your scope of where your threats exist with the software you build. Another one that surprised me, 94 days is the middle time or median time to remediate leaked secrets. That's over 3 months that threat actors have on average, that if they find a key, they can discover what it's used for and try to access different things. So that was wild or surprising to me. And then 81% of the threat actors were external, leaving the remainder to be internal threat actors, which is a little surprising as well. So not only testing your externally facing websites, but making sure you get the proper controls and roles within your applications and APIs, even internally, kind of that zero trust concept and mentality. All right, so taking a step above and looking at the program from a high level, what components make up a successful Appsec program, and then we'll dive into a little bit more into the testing and details of it. So I thought of, these are mine. I'm sure if you Google, you'll find different components out there, but these are the five I kind of logically separated what I thought would make up a good AppSec program. The first being the policies and standards that come from your governance, risk, and compliance department, and this is really just giving your developers clear standards on how to build the software, what repositories to go to, and giving them more of a playbook. The second very important component in my mind is secure code training. If we get really good at finding and identifying vulnerabilities, that's great, maybe even fixing them as well. But to fix the problem at the source, so here the concept of shifting left, is really to stop the systemic issue of injecting all these vulnerabilities and educating developers with proper training. There's a lot of training and a lot of responsibility developers and engineers have today, and educating them from when they start or get onboarded is an important piece. Number 3 is secure SDLC process. So this is all about integrating your tools into your CI/CD, making things happen automatically, and ensuring that the tools are integrated. And not just with the CI/CD pipeline, but also within the IDE. That's the earliest point where a developer can get some feedback on how their code is looking and detect any issues early on. Number 4 is application security testing, so making sure you have the right testing types depending on the application itself, the right level of testing maybe, depending on how important that application is and the frequency of it as well, this will be the majority of the presentation. And then last one, vulnerability management, so putting some effort around having like a risk register or an open vulnerability list that is managed and known by the different application owners. Application owners or product owners have a lot to worry about. This would be one more thing added onto their list of things. They want to at least know the risk. Sometimes the risk is accepted and it's not actually remediated, but educating the application owners and product owners on what risks they have out there is an important piece. All right, moving on to the software testing types. So before we dive into application security testing, I think it'd be a good just high-level quick overview of the different types of testing. You kind of split them up in 2 ways. There's functional testing and then there's non-functional testing. I'm not going to go through each one of these boxes, just to call out a few. For functional, you have the lowest layer of unit testing to test specific pieces of code, all the way up to user acceptance testing, where you have a dedicated, or maybe have a dedicated environment where real business users are going in, looking at whatever changes are going in and signing off on those changes. That's very important for the business users to be happy with the product, and therefore they're getting sign off. Switching over to non-functional. So the functional is all about what the app does. Non-functional is how does that app perform. And there's different types of non-functional testing, probably even more than what's on the slide here, but just to call out a few. Performance testing, making sure that the app runs stable under load. There's all different types of performance testing, stress testing, spike testing, but we won't go into that today. And then another one to call out, accessibility testing. So this is a newer type of testing that's spawned up over the last few years, and I find it pretty fascinating, is ensuring the app is accessible for those with disabilities. And there's been a lot of standards and tools even published to help with that. So these non-functional testing are a little bit of a niche and more of a unique skill set, but you'll see more of these jobs, I feel, pop up over time as companies start to realize that these types of testing are important. I think that covers most of it on this slide. Just looking through. All right, diving into the application security testing types. There are more types than this on the screen, but I wanted to call out a lot of the main ones here, talk about them from a high level, and then dive in a little bit deeper in a few of these. Yeah. So on the left-hand side, we have the testing types. What is it? If there's ID integration or not, who it's typically performed by, and then some high-level key characteristics of each of these. So who in the room has heard of SAST testing before? Anyone? That's the most popular one. If you've ever heard of security testing, that one's probably the one that your company's doing at minimum. This is all about scanning the source code for vulnerabilities. There are some level of false positives with it, and I won't go dive because the next slide we dive a little bit deeper into it. But typically this is in an early phase, it's automated, and it can find different vulnerabilities within the source code. And it's pre-runtime, that's an important factor to remember. Secret detection is sort of a subcomponent of SAST. You can kind of roll it up it, but there's been tools that have come out that have gotten really good at detecting patterns of certain secrets that are leaked and maybe committed. So that has evolved in the last several years. SCA is a wide encompassing topic, software composition analysis. You may have heard of things like dependency scanning or even license scanning. That's kind of all rolled up into SCA, which we'll talk a bit about as well. Typically, this is performed by the developers themselves or a centralized security team. It is dependency focused, automated, and it tracks a lot of open CVEs that are tied to the software components that are known and out there. The next one's a really cool one. I think the team members on my team find this one the most interesting is DAST. This is dynamic application security testing. This is where you get to start playing around with an actual running application in a test environment. You don't want to test against production, obviously. So if you're doing DAST testing, there's kind of different levels of it in a way. I call them out separately here, but DAST to me is more of a level one. It's automated. You configure tools to log in and maybe run some business flows or point, and it's really good at trying a lot of different things quickly. And then you have more of a manual application penetration test, which is more your traditional pen testing, and you're trying more advanced techniques as well. So for the next one, it's infrastructure as code scanning. This is all about the code. So as infrastructure has evolved over time, we want to be able to spin up infrastructure easily, have it source controlled, and even configured with different customizations based on your end customers. So if I'm a server guy or a database guy, no longer am I building that from scratch. I'm expected now to use different tooling like Terraform or other open source frameworks out there to spin it up and configure it in a certain way. So what's important about that is it's great and it's easy to spin stuff up, but making sure it's done in a secure way and having those controls. There's a lot of security tools out there that enforce it from a runtime or after it's deployed and can more detect issues. This scanning's a little bit pre that. You want to identify as you're making those Terraform playbooks or modules or infrastructure as code playbooks and be able to detect, hey, is my S3 bucket going to be open to the world if I write it in this way versus adding in this security configuration. This is also where GenAI can help you. If you're new to some of these concepts, you can use it as a personal assistant and ask it questions as you go through and making sure it's okay from a security check standpoint. And the last one is container scanning. So containers can be pretty complex. I don't know if you guys attended the container talk earlier this morning. There is a lot that goes on within containers, and making sure that your images are hardened or the packages that are pulled into those containers are secure. And container scanning is one of the more newer types of security testing, I would say, and there's definitely tooling out there that handles this. And this is more runtime focused, and you can deploy it in your running either Kubernetes environment or other types of container environments to find issues. So a lot of different testing types. Sometimes you will focus in one and become an expert in one. Some others will just be more wide across and know the basics in each. And then some of them, or even developers, are expected or trained to be able to do themselves, like SAST testing, for example, the whole shift left concept. All right, time to dive a little bit deeper into each testing type. So the format will kind of remain the same over the next few slides. So some of the strengths of SAST in secret detection. Early detection. So this is the most cost-effective way to fix vulnerabilities. There's a lot of time and effort that gets spent into doing SAST testing, identifying a vulnerability, writing it up, meeting with the right app owners to communicate it. Then they have to do their own research, and they have to implement the fix. And then we have to retest to make sure the fix isn't breaking more things or ejecting more vulnerabilities. And there's the whole release and audit and documentation portion of it. So is you can imagine one small vulnerability, you can put a price tag on it from a pretty high standpoint. If you're in a larger organization that may have more red tape than a smaller organization, for example. The other strength is its IDE's integration. So a lot of the SAST tools that are out there have plugins with give you live feedback. So you'll see ongoing processes and scanning and provide you lists of issues that are categorized by their default severity. And the other great thing is a lot of this is automated through your pipeline itself. Weaknesses, SAST can be particularly noisy. If you haven't configured your SAST tool, or if you're just using out-of-the-box rule sets, and just the nature of how the testing works, SAST only has so much context about your environment and the way your application is running. So it can have a lot of high false positives, and developers do not like false positives, and no one really likes them, but they come with the nature of the tools. I've heard some industry standards around 10% of the findings or so are false positives. If you're benchmarking around there, you're about average. You try to shoot for a little bit better than 10% for some of the issues that come out. And then another weakness is depending on the type of scan. So just your basic scans may not be doing cross-file or cross-function analysis. For example, SEMGREP, I think out of the box is very lightweight and it's very quick, and it might not do as deep of a scan as, for example, like an enterprise checkmarks tool, where it's taking a lot longer to deep dive in and go through from file to function. You might be thinking, well, why is it important to go from cross-file or cross-function into different files? One thing, at least my team members always are challenged with, is tracing back user input. So determining where this variable is coming from, what functions it's propagating all the way up to, and it can be challenging to trace that code back. And SAST tools out of the box sometimes don't do a great job with that. Some vulnerability examples down there. These are probably pretty popular ones you guys have heard of. SQL injections, cross-site scripting, and hard-coded API keys or secret detection, which is a sub-part of SAST in general. And then some of the tools on there, you'll see some of the names kind of remain from a commercial side slide. If you would have done the same slide 10 years ago, you would have saw a lot less names on the commercial space. What has happened in the industry, this is common across a lot of tools and just companies in general, these larger companies are buying other companies up to complement their product suite. So more and more companies are trying to be a holistic, solve all your problems in one across their tool sets. JFrog has expanded theirs, GitLab has, Checkmarx has bought companies over the years and expanded out their lineup as well. So I at least wanted to show, there's definitely some other open source tools out there. I just chose the popular standard SEMGREP. There used to be a few more open source projects, but it seems that SEMGREP has become the kind of, I don't want to say sole winner, but some of them have gone down and combined into SEMGREP instead of maintaining their own.
Yeah, we're using Trivy, and that's very good as well.
Trivy, yeah, I did hear that tool this morning. I probably should have added that into the presentation. I was talking with someone, and not a tool I'm too familiar with as well. Anything to add? Yeah.
I think on open source side, there's some like language specific ones, like GoSet is pretty good for Go, but it doesn't handle that for us.
Right. Yeah. Absolutely. Yep. There's language specific ones as well, and that's where we'll find a little bit more in SCA. So I'll start there with the tooling. There are some open source tools for software composition analysis and language specific ones. Great transition. So if you're in there writing maybe an Angular UI using Node, you've got your out-of-the-box NPM commands you can run. An NPM audit is one of them. I forget the exact Python, but similar for pip packages. This is all about checking your dependencies and seeing if there are known CVs out there that are tied to those dependencies. And these tools do a great job of pulling that information in. And just because you did a scan today on your code and you don't change anything tomorrow, if you do a new scan tomorrow, or at least check the same packages, you might have more or less, or there might be a difference in the number of CVs that are associated with your code. So this can cause some challenges with maintaining, and if you think about software from an enterprise standpoint, the number of applications and the number of packages that are pulled in, this data, you can get very overwhelmed very quickly with the data that SCA tools spit out. There's multiple components of it. There's the actual dependencies themselves. There's your base images that contain dependencies out of the box. And there's also the license portion of it, which we didn't really talk about at all. If you're selling commercial software, there are certain licenses that you're allowed to include and not include within your software. And I think that's a big gap, at least from my talks to other individuals in the field, is that's something that hasn't really been figured out from an industry standpoint or even a tooling standpoint. So some strengths of SCA is that you get to have some awareness into what licenses are out there, and SBOM generation. So SBOMs, software bill of materials. This is all the things that make up your software. It's a great concept. Everyone should have SBOMs for the software that they build and test. It makes it more transparent internally of what's included in your software. And you can have a record over time and do great things like SCA scanning with SBOMs as well. There is some IDE integration as you code and pull in a new package. It can do a scan on that and make sure that there's no high severity CVEs with it. There's also some automation through CI/CD pipelines with this type of testing and tooling, and it's pretty quick at how it operates. Some weaknesses is just because it's identified as CV doesn't necessarily always mean that there's a fix, and also contextual analysis can be difficult. So looking through all of this data, you may not know if this CVE even applies for your software, and that can be challenging from a security tester and as well as a developer trying to fix the open issue that's out there. So there's some noise in there, I would say, and some contextual analysis can be difficult. Some of the products offer, like they put their own research on top of the CVs, and then you can also combine it with SAST, where your SCA tool and SAST can kind of talk together, and then it can determine or make a better informed decision or recommendation on, is this truly applicable or not. It's rapidly changing. There's new CVs coming out every day. There's new packages that are changing. And then some of the vulnerability examples. On the left-hand side here, we see log4shell. So who is around or in a security role for log4j? So that was like my first week as a going into my position, being over a security testing team, and after the first week or two, I was like, is this how it always is, guys? And they're like, no, this is a more unique situation. So I thought I learned a lot from that, but this is the type of testing that could be done to sort of detect some of these vulnerabilities that are out there. The license violations, which I mentioned, and there are some interesting ones as well. So OWASP has a bunch of lists, which we'll talk about in a bit. But there are some attacks out there, one in particular, compromise of legitimate packages. So this is when a developer will join anonymously to a project, have some legitimate contributions to that project, build trust up with the other contributors, and then what they'll do is then they will inject some malicious code after they're deemed a maintainer or maybe an owner of that project, and everyone who's been using that project for years now, they may or may not be aware that malicious code has been injected. There was a really interesting story where a guy from Microsoft found something in like the Linux kernel, and he posted a research about it, and he noticed some latency differences for doing some simple commands, and they were able to find and stop this from being actually loaded in, and it would have had a huge wide impact across the world, and it was a really interesting read. But like those type of attacks are just so unique in the way, and will all roll up to dependency management. Name confusion attacks, we learned this a little bit about the top level domain, if anyone went to that talk a little bit. So a package maybe have this one name, and they might change like an L to an I or a 1, or they might misspell it slightly. You might think you're downloading a package, but you're really downloading a different package instead. So that's some name confusion attacks as well. Tooling out there, like I mentioned before, I think a lot of the similar players are out there. JFrog, I think, particularly does a pretty good job at storing artifacts and being able to scan all those artifacts as well. That's one tool I've used over the years and had some success with as well. All right, going into DAST and application penetration testing. So some of the strengths here is you get to find vulnerabilities that you can actually reproduce. So showing it in code is always great. It could lead to some false positives, but when you have a demo you can bring to a development team and say, hey, look at what I could do to your application, or look what data I could steal out, or look at this bad configuration that's out there running live in either your API or web application. I feel like it has a little more weight to it, and it's more fun for the testers to actually go through and do. So it's runtime detection, like I mentioned, and what's nice with some of the DAST tools is you can do real world business flow. So maybe you have a sign up flow, you buy some products, or you have certain business flows you want to test every release. You can use these DAST tools to not only log in and go through, but you can use it to actually use test data to fill out forms and submit things and go across depending on the tool you're using. It's automated and it has a pretty deep depth of testing. Some of the weaknesses, if you are doing those business flows, now you have to manage users, you got to manage test data, you have to make sure that the application is up in those environments. Test environments, if anyone's worked in test environments, sometimes they're not always behaving as you'd expect them, or maybe not as functional as you'd hope when crunch time comes to test. So the vulnerabilities example here, that there's some common names up there. Privilege escalation is a little new, and then file upload, I'll call that one out. That one's pretty interesting. I think some of the web apps out there have a lot of file upload functionality. So making sure that you're only allowing certain types and scanning them for malware, that's something that an application pen tester or DAST could discover and try out. Last weakness to call out, this type of testing takes time and a unique skill. It's not something that can be done in minutes or hours. It's more typically longer than that, and it's a niche set of skills.
Question?
Yeah, go ahead.
All right, so there's often confusion, around DAST and IAST.
DAST and IAST, yeah.
And, beyond having lower false positive rates,
Yep.
are there other typical use cases where you would prefer IAST over DAST? And how do you navigate the performance issues that IAST because of
Yeah,
agents?
that's always the concern with IAS. So for those who are not familiar, IAS is like the next evolution of DAST, where you actually install an agent that goes into your application, and it will be able to listen to traffic, and it will combine that with the DAST data itself, and then it will hopefully give you less false positives. If you ever talk to anyone who has an application, you say, let me install an agent where your app runs, they're going to be very hesitant. That's my experience. No one ever wants more latency or more issues that could go wrong. So I don't think IAST is maybe as popular as some of the other types, but the intent of it is really to reduce the false positives. So it's really just depending on, do you care more about the false positives, and can you take that maybe slight hit in performance and convince your product owners, or are you okay with just out of the box DAST? Sure, we'll take one question.
Just to add to the slide we had up, the previous one.
Yeah.
So for the Burp Suite report swinger,
Yeah.
one of the downsides is obviously you can use it for quite a bit.
Yep.
With the plugin suite, but what happens is some of them are very resource heavy.
Resource intensive if you're using Burp
that
plugins,
can
absolutely.
bog it down big time. So it's just
Yeah.
knowing
Knowing what plugins you have is important. It's awesome. Burp Suite Pro is like the tool to use for pen testing, app pen testing for sure. It's got like repeater. It's got all these great functionality and features and a great community around it. But absolutely, if you're depending on how you use it, you could go very slow, and it can be ineffective at times as well. OS SAST, this is another one to call out from Open Web Application Security here, yeah, that's about it from a tooling standpoint. All right, just a couple more slides to go here, and then we'll dive into the Kahoot. Vulnerability triage and reporting. So now we've done all this testing, we have all these vulnerabilities, and how do we communicate that effectively, and what type of reporting is used. So if you've ever been involved in a third-party test, you'll see a nice pretty report come through with colors, kind of looking at what's on the screen with severity differences, and it's very organized. I think that's important for any type of testing to be done, having a standardized format that prioritizes your issues, because development teams don't have an unlimited time and budget. They want to focus on the most highest impact, the easiest to fix issues first, and they want an easy way to do that. They don't want to waste time on confusing report. So the tools aren't perfect. The goal here is to reduce the false positives, and as I mentioned, Gen AI can help learn these. Prioritization with risk factors, so don't always take what the tool says. There are things to consider beyond the severity that's recommended by the tool, like attack vector, impact, complexity, privileges required to actually perform the attack, and yeah, the impact. So is the application or the attack going to expose something on your customer-facing core web application, or is it more just an internal app that doesn't have sensitive information, right? Those can be the same SQL injection vulnerability for each of those could be varying different impacts and urgency to communicate. Another recommendation is use some of the standards that are out there. So CVSS scores are out there for a reason. They help you score severity. And then OWASP Top 10 has a lot of categories. So who's heard of OWASP Top 10 before? A categorization. So it's a great way to categorize vulnerability or types or categories of vulnerabilities into the top 10 list. But they also have, and OWASP stands for Open Web Application Security Project. They have a bunch of other lists they've published as well. So not only web apps, they have one for API, one for mobile applications, one for LLMs that recently came out, one for open source software, which has some really interesting categories, and I think those are the main ones that I know of and have looked at before. So wrapping this up, reporting matters. Know your audience. This is for any type of presentation. The information you give to an executive level is going to be very different than the information you need to be provided to the devs themselves to fix the CV, or the vulnerability issues themselves. So last slide here is getting started in Appsec. What kind of resources are out there if you're interested in this type of field, or maybe want to play around with some of these testing types? And this is not a fully inclusive list. I'm sure if you Google or use your favorite AI agent, you can come up with some new ones. But so some free learning resources. OWASP, I encourage everyone to go out there and look at not only the top 10 list, but some of the other projects that are out there. Maybe get involved, maybe something sparks your interest and you want to help contribute to. Portswigger has a web security academy. This is more hands-on training. Highly recommend this if you're interested in application penetration testing. And then there's some other tools out there which do a really good job of the offensive side. So you can look at code and try to look at a SQL injection and ways to look at it. But when you see it from the offensive side of things and kind of pair the two together, it's almost like another light bulb goes off on your head, and it makes it easier to understand. So I think some of these tools have progressed a lot over the last few years. It's showing that offensive side combined with, hey, here's how to do the attack and here's how you fix it. And to me, that's the best way I've found for my team members to learn and train. Some AppSec job titles. I just threw out a few. There's probably a bunch more out here. Test engineers, application security engineers. I would say don't get thrown off just with the title. A lot of companies now are moving to more generic titles and descriptions, so you don't really know until you meet with them and see. It might be a generic, like DevSecOps. Some days I feel like more of a DevOps engineer than I do an actual security tester or manager, because we work with them so closely for the pipeline work. So don't get discouraged just on the titles themselves. Make sure you go to the next step of screening to learn what the position does. There's some skills posted here and some certifications. I would say don't go crazy on the certifications. I've done a lot of interviewing where people have had certifications and maybe it didn't fit as well for the position. I think they're useful to learn specific knowledge. Some of them are pretty expensive to get as well, so just be mindful and balance maybe your own projects and learning versus the certifications themselves. All right, so the last thing to call out here is some skills. These are some important skills for a security tester to be successful in their role. And some of these are across all types of testing, but communication and collaboration, there's a lot of working together that goes on within the teams to confirm. Analytical and problem solving, a lot of times you have to dive deep to uncover root cause. Root cause analysis is a very important part of the job in any type of testing role. And continuous learning, as we all know, things change day to day, especially with AI and agentic AI coming out now and evolving. You just have to be open to changing and learning new technologies and ways of testing. And then the ability to read and understand code. So you don't have to be an expert actually writing the application, but knowing a basic level understanding and what does this code do, or using tools to understand that code. All right, so we're at 3:40 here. So next, gonna do a quick Kahoot here, and I'll give some T-shirts here. I got some OWASP T-shirts in different sizes and colors, and we'll give some T-shirts out to the top three participants in the game here. Let me go over and actually start this. This works. Looks like it's coming up with an error. 1 second here. Apologize for that. I'm not connected to the internet. That would be why. I was before. Try that again. So while I'm pulling that up, any questions? That's kind of like the end of the. Any questions or things to share with the group? Maybe you guys have come across tools that have been helpful in the past, or have an experience to share. See a question in the front?
I don't know so much if it's a question, but a comment, and maybe you have an answer, a comment about my comment, but on your slide about how to become good in appsec or something, your number 2 was something about training developers or something.
Appsec program. So build a holistic program. It's important for secure code training. Correct.
Yeah, secure code training, exactly, number 2. And so what it's been my experience so far is that you can have the most advanced coders on the planet, but many times they are so overworked, and their timelines are so tight, and the organization doesn't give enough money to either hire enough coders, or alternatively even provide testing tools, secure testing tools.
Underfunded is a big challenge we face in our field. Yep.
And so it's very difficult to write secure code when all you can do is like race to cobble something together that works.
Yeah. It definitely depends on your sprint cycles, like how quickly and often you reduce or are putting out features or changes to your code. And I would say that's definitely a challenge we face, is funding and time is priority day. Developers have thousands of things to do, and unfortunately vulnerabilities fall down here. Like I manage a performance team and a vulnerability team. When an app team has a performance issue versus a vulnerability issue, the app team is way more engaged and more wanting to fix their performance issue versus a vulnerability. So fortunately, sometimes it falls down. So hold on for one question. So if anyone wants to join the game here, we'll get started here in just a minute. I'll take one more question. You just have to scan the QR code. Let me click on it to make it bigger. There we go. Does that make it easier for everyone to join? And then go ahead with your question if you'd like, and then we'll get started.
I guess it's also more common. One of the things that I've observed in the software development was during the very early design.
Threat modeling and architecture.
And there's hardly any attention paid to security provisions and issues like that. And that's I teach software engineering. And basically, it's so before you write a single line of spec, forget the code, spec. That has to be one of the top priorities.
Sure.
And
it's a good point to make, yeah.
And it seems like that's where most of the shortcuts are, especially on the management side.
Yeah. Yeah, architecture is.
When you get into this.
Yep, absolutely. Focus in architecture and threat modeling. I don't really talk about that. It's connected in a way to application security, but I left it out of this speak since there's so much information already. All right, looks like we got a bunch of people joined. We're going to start here. There's 20 seconds for each question. There's like 8 or 9 questions. And there's a leaderboard, and you're also awarded for right points and how quickly you answer. So those are kind of the rules, and we'll go through. The questions get harder as it goes as well. Good luck to everyone. The first one is, what is the key reason apps are targeted by threat actors? All right. Apps often have exploitable flaws. That was an easier one here. All right. Daniel's in the lead with 902. Good name. I like that name.
Is it you?
No, that'd be playing my own game, I think. All right, which of these is not a component of an application security program? So we talked about 5 components. Which one is not part of it? Right. So phishing awareness campaigns are not application security, it's more general security awareness campaigns. So most people got that one right as well. All right, moving on. We have a change in leader here. All right, professor. All right, question 3. Which of these types testing is not non-functional? Not classified as non-functional. Like a tongue twister. I don't love the word non-functional either. Like when I say I'm a non-functional manager, it's like doesn't sound right. Testing manager. All right, unit testing is more of a functional type of testing. Correct answer here. All right, MMCS is in the lead now. We've had a new leader each round. This is another easy one. Right, so most people have answered already. They're getting the hang of answering quickly. Okay. Yeah. All right, static application security testing is the correct answer. Right, MCS is still up there. What type of testing scans source code before runtime for vulnerabilities? All right, SAST is the correct answer here. So SAST is what runs before runtime. What is the strength of DAST testing? AppSec. A couple questions left. Detects runtime's flaws in the running application. That's the important piece here for DAST, is you get to test against a live application. Right, 2 more questions to go, I think. 7, 3 more. Primary goal of vulnerability triaging and AppSec. Right, these are rock stars here. Next. Which of the following is not an OWASP top 10 list? We talked about a few top 10s out there. Which one is the one that's not a top 10 project from the OWASP community? Getting a little harder now. right, we had a few less answers there, but most people got it. Top 10 risks for Python. There may be a top 10 list out there, but it's not actively maintained by OWASP. Good job there, 18 folks. All right, last question. What was the median time to remediate leaked secrets from the Verizon report that we showed in the beginning?
That's a guesswork.
24 days, 163, 24 hours, or 33 days is the answer here. All right. Let's see our final winner here. Hoping it shows the top 3 at least. All right, so come up after me if you're one of these top 3 and we can get you a size and a color. I can't read all those names that quick, but
Who are you? Who are you?
All right. So that concludes the talk. We've got.
One leaving a secret.
There are more people.
There we go. Yep. So any final questions? Any comments? Stories to share with the group? We're just about at time. All right. That's it. If you want a T-shirt, please come up.